In this lesson, we're going to discuss some properties of logarithms that will help us solve exponential equations where we clearly do not have an integer as an exponent. The following property of logarithms can be used to help rewrite logs with powers, such as this one, log base 2 of 4 squared. The form is log base b of an answer capital B to capital A. We bring the exponent a out into the front, and we simply have log base b of b. Let's take a look at a real example. So given log 6 of the 4th root of x, this becomes 1/4 log b of x. Remember, the 4th root of x can be written as x to the 1/4, and that's how we get our exponent to bring forward. Let's take log 3, 9 squared. We bring the 2 exponent to the front. We now have 2 times log base 3 of 9. We're going to solve exponential equations with logs. We can use the property we discussed to solve exponential equations, again where there is obviously not an integer exponent that would work. We will use the common log of base 10. This is the log button on your calculator. Here we have 8 to some power equals 7. Clearly there is no integer answer for x. But we can take the log of both sides of this number. It's just like any other algebraic property. If we do it to one side, we can do it to the other. So here it is, log 8 to the x equals the log of 7. Now we're going to use our property. We're going to bring the x to the front. X times the log of 8 equals the log of 7. Now, if I divide both sides by the log of 8, I get x by itself. So x is equal to log 7 divided by log 8. And using your calculator, you should get an approximate answer of 0.9358. Now you're going to try. You're going to solve for x in the equation 7 to the x equals 9. You will pause the video while you work through the problem. When you're ready, restart the video and check your work against mine. Let's see how you did. So I'm going to take my equation 7 to the x equals 9. I'm going to start by taking the logarithm of both sides. So I'm going to start with the log, common log of 7 to the x. Now we don't write the base 10 because, like square root, it's one of the more common logarithms you're going to use, so we don't bother writing the 10 in the base location. If you don't see it, you assume it's log base 10. And log 9. Using the property, I can pull the exponent x out in front, so now I have x times simply the log of 7, still equaling the log of 9. So to get x by itself, I divide both sides by log 7. So x is equal to log 9 divided by log 7. If you are asked to give an exact answer, then you would have to write down log 9 divided by log 7. That would be the exact answer. But if I wanted a decimal approximate, then I would calculate the log 9 in my calculator divided by log 7, and it should come out to be about 1.1291.